Welcome. Today, we're diving into the world of Model Context Protocol, or MCP, and how it's revolutionizing the way large language models interact with real-world data and tools. Instead of treating AI as a mysterious black box, MCP provides a structured, standardized way for models to access information and perform actions. Think of it as the USB-C port for AI, creating a universal connection between language models and the servers that hold your data or execute your tasks. In this video, we'll walk through what MCP is, why it matters, and how you can build your very first MCP server using FastMCP. Let's start with the basics. MCP stands for Model Context Protocol. It's a standard protocol designed to let language models communicate with external systems securely and consistently. While APIs are built for human developers, MCP is tailored for large language models, giving them the ability to read data, perform actions, and even guide interactions through prompts. With MCP, you can expose data as resources, provide tools for actions, and define prompts to shape how models interact with your systems. This opens up a world where AI can use your data and logic in real time. You might wonder, why not just use the official MCP SDK? FastMCP takes things further by offering a production-ready framework that's both powerful and developer-friendly. It comes with enterprise authentication, client libraries, testing tools, and automatic API generation. FastMCP makes it easy to build secure, scalable MCP applications that can integrate with major providers like Google, GitHub, and Azure. Whether you're deploying to the cloud or your own infrastructure, FastMCP simplifies the process and lets you focus on your application's logic, not the protocol details. Before building your first MCP server, you'll need to install FastMCP in your Python environment. You can use pip, but the recommended way is with the UV tool, which efficiently manages environments and dependencies. Just run of pip install FastMCP in your terminal, and you're ready to go. This simple setup step ensures you have all the tools you need to start building powerful MCP servers with minimal hassle. Every MCP server starts with the FastMCP class. This class represents your application and manages your tools, resources, and prompts. Let's create a simple server that adds two numbers together. In your server.py file, import FastMCP, create an instance, and define a tool using the @MCP tool decorator. The add function takes two numbers and returns their sum. With just a few lines of code, you have a fully working MCP server ready to handle requests. To run your MCP server locally, simply open your terminal and type fastmcp run server.py. This command starts your server, making it accessible for clients to connect and use your tools. For web-based deployments, you can use HTTP or SSE transports by specifying them in the run command. For example, running with HTTP on port 8000 is as easy as mcp.ru transport equals HTTP, host equals 127.0.0.1, port equals 8000, path equals MCP. Now, your server is ready to accept remote calls and perform computations. FastMCP makes it easy to expand your server's capabilities. Tools are just Python functions decorated with @mcp.tool. You can add as many as you like. For example, add a multiplication tool by defining a multiply function. FastMCP automatically generates schemas from your function signatures and docstrings, so clients always know how to use your API. This flexibility lets you build rich, interactive servers tailored to your needs. Resources in MCP represent read-only data that clients can access. You can create static resources, like a version number, or dynamic templates that take parameters, such as user profiles. By decorating functions with @mcp.resource, you expose these resources to clients. This approach allows your server to provide both static and dynamic information, making it a versatile backend for AI-powered applications. FastMCP gives you access to the session context within any tool, resource, or prompt by including a CTX context parameter. The context object provides powerful features like logging, LLM sampling, progress tracking, and resource access. For example, you can log messages, read resources, and even ask the language model to summarize content. This makes your tools smarter and more interactive, enabling advanced workflows and real-time feedback. Once your server is running, you can connect to it using the FastMCP Client class. The client can communicate via STDIO, HTTP, or SSE, and even run in-memory for testing. By listing available tools and calling them remotely, you can build complex systems that interact with multiple MCP servers at once. This client-server architecture is the backbone of scalable, distributed AI applications. Security is crucial when moving from development to production. FastMCP supports enterprise-grade authentication providers like Google, GitHub, Microsoft Azure, Auth0, and WorkOS. With just a few lines of code, you can enable secure OAuth-based access, ensuring only authenticated users can interact with your server. FastMCP handles tokens, refreshes, and error handling automatically, so you can focus on building features, not managing security. Deploying your MCP server is flexible and straightforward. For testing, the FastMCP run command is sufficient. For production, you can deploy to FastMCP Cloud for instant HTTPS endpoints and built-in authentication, or self-host using HTTP or SSE transport. A simple deployment command like mcp.ru-n-transport equals HTTP host equals 0.0.0.0 port equals 8080 gets your server online and ready to connect with language models, web clients, or automation workflows. Once your MCP server is running, you can connect it to a large language model. This allows the LLM to securely call your server's functions, read resources, and perform actions as part of a conversation. By defining an MCP configuration file, you make your tools discoverable to the model. The LLM can then use your server's capabilities as if they were built in, enabling dynamic, real-world interactions in chat-based environments or custom applications. Let's see how this works in practice. When your server exposes tools like add or summarize, the LLM can call them directly during a conversation. For example, if a user asks to summarize an article, the LLM calls your summarize tool, processes the result, and responds with the output. This seamless integration lets you build intelligent systems that combine the reasoning power of language models with the logic and data of your own backend. FastMCP makes it simple to bring your data, APIs, and tools into the world of AI through the Model Context Protocol. With just a few lines of Python, you can create powerful MCP servers that connect to language models, automate workflows, and handle real-world logic securely. Whether you're building a quick demo or an enterprise-grade system, FastMCP gives you the shortest path from idea to production. Install it today, start your first server, and explore how MCP can unlock the next level of AI integration.